Okay, we're going to do a couple of examples for you guys to see some more on converting, using stoichiometry to convert between grams and moles, moles and moles, grams to grams. And I'm going to do this in a series of, I think, maybe 2 or 3 videos. So this is going to be part 1. We're going to do mole to mole conversions. So this is a reaction I'm going to use because it's got a nice mix of different coefficients. And the first question we're going to ask or answer is, if I had 7.60 or 7.6 moles of oxygen, how many moles of carbon dioxide would that make? So we're going to use our balanced equation to set up our conversions to be able to go between the different, in this case, oxygen and carbon dioxide. So we always start off by writing out the value that we are given. We know that we have 7.60 or 7.6 moles of oxygen. We need to convert that. So we're going to set up a conversion fraction. And in our fraction, in our conversion, this is where our coefficients are going to go. So we know that in this reaction, based on the balanced equation, 11 moles of oxygen will be equivalent to or equal to 8 moles of carbon dioxide. So we are going to put 11 moles of O2 on the bottom, and that 11 is coming from the coefficient. We need moles of O2 so that we can cancel out this moles of O2. Remember, that's the whole idea behind our conversions. Based on our equation, 11 moles of O2 is equivalent to 8 moles of CO2. So that's going to go on top. The question is asking for moles of CO2. So if I were to cancel out the units, I'm left with the unit that we are looking for. I forgot to put moles. And we're done. All we need to do is calculate this out. And the answer for that is going to be 5.5 moles of CO2. I believe your calculator comes up, it has 5.527. We only need 2 significant digits because we're going to just use these 2 to determine the number of significant digits on our answer. We're going to drop that part and we are left with our 5.5. I'm going to leave this problem up. And then the other problem I'm going to work here is if we had 4.6 moles of this compound, how many moles of O2 would we need to react with it? So again, we're always going to start off with the value that we're given. We're given that we have 4.6 moles of that compound. I don't know the name of it. I'm not going to look it up. I just made it up. We need to convert that, so we need to cancel that unit. We look at our conversions to do our mole to mole, so we can convert between moles of this compound and moles of oxygen. And based on the ratio, 4 moles of this compound would be equivalent to 11 moles of oxygen. Cancel the units that are the same. We're left with the unit of moles of oxygen, which is what we're looking for. That's the question. So we're done. All we need to do is calculate it out, and we get a value of, on our calculator, 12.65. But since this only has 2 significant digits, we only need 2 significant digits here. So I'm going to make that 13, or 1.3 times 10 to the first moles of O2. So these are 2 examples of going from moles of a compound to moles of another compound, or moles of one reactant to moles of another reactant or product. And they're basic, simple one-step problems where you're using the ratio based on the coefficients to make the conversion.